Hey guys, over the last couple of days we've been talking about functions and the way that they take an input and convert it into an output. We've looked at this with graphs and tables and equations, but ultimately we just care about the rule. Input leads to output. Today we're going to be discussing the average rate of change. You're probably familiar with this already because it's really similar to the idea of slope from 8th grade. The only difference being that when we talk about average rate of change, we don't need to have a straight line. We can have something like a curve instead. Either way, our goal today is to find the average rate of change of various functions in order to summarize their behavior. Let's look at our first problem. In exercise 1, Max and his younger sister Evie are having a race in the backyard. Max gives his sister a head start and then they run for 20 seconds. And the distance they are along in the race in feet is given below, with Max's distance given by m of t and Evie's given by e of t. I'm going to try to use blue to color code things that relate to Max and red to color code things that have to do with Evie. So if we give a look to this right now, we can see a couple of things at the outset on our graph. I can see that it looks like one person has started ahead. That's Evie, who's been given a little bit of a head start here. And then Max is behind her. If we're looking at who's going faster, you can tell that Max is going a little bit faster based on the fact that his line is steeper than Evie's. So those are things that we're going to have in mind and become confirming when we go through our problem. So first things first, they give us in function notation that m of 12 is equal to 30, and they want to know how will we interpret this. So m is going to be this line right here, and when I go to interpret something like this, I notice that they gave me two numbers to correspond to our two units here. Anytime I'm given function notation like this, one of these is corresponding to a distance and the other is corresponding to the time. So we'll use a little bit of common sense to figure it out. This is where our x piece goes. X is always inside our parentheses here, and since x is 12, that tells me that the time must be 12 seconds. So after 12 seconds is the first bit of info that I'm interpreting. And now I need to use this other side. Well, if x was seconds, then my y piece right here is going to be referring to the distance here in feet. So after 12 seconds, Max is 30 feet from the start. Next up, it says that if both runners start at t equals 0, how much of a head start does Max give his little sister? T equals 0, of course t is kind of replacing x for us here, so that's referring to this line right here, right at the beginning. I don't know if you guys can see that or not. Okay, so along this point we've got two different values to compare. Here's Max at the very beginning. He starts fair at 0, 0, but he gives his sister this head start. This head start right here, and all that we're looking for is the distance between these guys. So how much of a head start does he give? Well, there's 5, 10, 15, 20, 25. 25 feet. Because the y-intercepts are 25 apart. Does Max catch up to his sister? Well, looking at a graph right here, I would know that he would catch her when the lines kind of hit each other, when they intersected. And since that doesn't happen, I would say that no. No, the lines don't intersect. Finding intersecting lines is going to be a really important part of our next unit on linear growth, because that's how we're going to answer a lot of questions, is when our two equations become equal to each other. Okay, where else can we go with this? How far does Max run during the 20-second race? So the whole 20 seconds is this entire thing, so all the way from 0 to 20. How far does he go? Well, he starts at 0 right here, and then winds up finishing at this spot. If I follow that over, that gives us a distance of 50. So Max goes 50 feet. Then we also want to know, how far does Evie run? Well, looking at Evie, we know that she started here and ended here. She ended at a distance of 60 feet, but she started with a little bit of a head start, right? Of 25 right there. So we need to find the difference here. 60 minus 25, there's our calculation, is 35, so she has gone 35 feet compared to Max, who's gone 50. So how fast do they both travel? What are their speeds in feet per second? We're going to need to use decimals and units on these guys. But what we know is that the entire race lasted 20 seconds. All right? Now, Max went further than Evie did, but he didn't quite catch up to her because of the head start that he gave. So while this makes it look, our graph makes it look like Evie won the race, we check out our speed. All I need to do is divide the distance we've traveled, which is 50 for Max, by the number of seconds that the race took, which is 20. 20 goes into 50 2.5 times, so Max's speed is 2.5 feet per second. Evie's speed, on the other hand, we're going to go ahead and divide our 35 feet by 20, which equals 1.75. So she's going 1.75 feet per second. And you can see why Max was able to kind of close the distance, because he's definitely going faster than Evie is. Cool, what's next? Alright, in our first exercise we were calculating the rate and the function's output values and how they were changing compared to their input values. This is known as finding the average rate of change of the function, and you've probably seen it before because, as we said, this is basically finding the slope of our line. There's a formula for this. It looks really gross and complicated, and you know what? It's not. Because instead of looking at it this way, I'm mostly going to look at it this way. How much have your y values changed divided by how much have your x values changed? Let's go ahead and try that in a couple problems. Okay, exercise 3 says consider the function given by f of x equals x squared plus 3, and we want to find its average rate of change from x equals -1 to x equals 3. I'm going to go back to that formula we just had a second ago, which was change in y. So that's our y change divided by our x change. Now, y, as we'll note, is the same thing as f of x. This right here is really the same as f of x here. So let's go ahead and look at our problem. If I'm going to find out what the y values that correspond with these are, I'm going to have to plug in my x values as inputs. So let's go ahead and do it. If x is -1, I'm going to plug that in here. F of -1 is equal to -1 squared plus 3. Then we simplify, so f of -1 is equal to, -1 times itself is 1 plus 3, so finally f of -1 is 4. I plug in -1, I get 4. Okay, let's do it again, but this time for an x of 3. So f of 3 is equal to 3 squared plus 3. Then square our 3, take care of that exponent. 3 squared is 9 plus 3. So finally, f of 3 must be equal to 12. Now we'll go back to our y change over our x change. So our y values are going to be represented by, let me do it in pink, our y values right here. Our y change is going to be, well, our y values were 12 and 4, right? So let's just subtract these to find out how much they changed. 12 minus 4 divided by, let's see, our x's, give me a green. X change, well, our x values were 3 and -1. So we have 3 minus -1 equals, I don't really have room for that here, so equals 12 minus 4 is 8. 3 minus a -1 is the same thing as 3 plus 1, so that's going to be over 4 for a grand total of 2. Okay, so our average rate of change is 2. As we look at this problem, went from 4 to 12 by going 2 every time we change this. What this means is that if I built a table, and you don't want to write this because I'm going to erase it eventually, but if I had a table that went x and then y, and it started at -1, We know that negative 1 gives us 4. If we follow our rate of change, every time I change this by adding 1 to it, that means that I'm going to change this by adding 2 to it. So 4 becomes 6, and then the next line 6 becomes 8, and the next line 2 becomes 10, and then the next line 3 becomes 12, which matches up with what we had right here. Cool? Okay. Let's look at another way that you can be asked one of these problems. The function h of x is given in the table below, and which of the following gives its average rate of change over the interval 2 less than or equal to x, which is less than or equal to 6. So they give us a table to work with, which is really nice of them because we don't have to plug anything in here. But they do specify that we need to go from 2 to 6. So I'm only going to be looking at this section of my table on both the left and the right side. So let's go ahead and check out our change in y. My y change was 3 and 9. Notice that I'm going to use the latest entry in my table here and start there. So 3 minus 9. Over, on the blue side, we have 6 minus 2. So 3 minus 9 makes negative 6. 6 minus 2 is 4. And we have negative 6/4. I'd notice that that's not one of the options over here. Don't be tempted by this. We definitely have a negative, but we can reduce this. 2 goes into negative 6 negative 3 times, and 2 goes into 4 twice. So this is the same as negative 3/2. Number 1 is our answer. Okay, so how much do your y values change over how much do your x values change? Let's go ahead and do one more before we call it for the day. Francis is selling glasses of lemonade, and the function g of t is equal to t squared plus 4 divided by 2, which models the number of glasses she's sold after t hours. What's the average rate at which she is selling lemonade between t equals 2 and t equals 6? So these are, we can think of these as our x values. 2 and 6. I can already tell when I go to do change in y over change in x that I'm going from 2 to 6. So I'm doing 6 minus 2 gives me 4 on the bottom. But we need to plug in our values to see what they create when we plug them into our equation. So let's go here, and I'm going to plug in t equals 2. G of 2 is equal to 2 squared plus 4 divided by 2. G of 2 is equal to 4 plus 4 divided by 2. So 8 over 2, which is equal to 4. So when I plug in 2 right here, I get 4. What happens when I plug in 6 instead? G of 6 is equal to 6 squared plus 4. Then we'll divide by 2. So g of 6 is equal to 6 squared, which is 36, plus 4 divided by 2. This is 40 divided by 2, which equals 20. So when I plug in 6, I get 20. And I make sure that my 20 and my 6 line up over here. I plug in 6, I get 20. I plug in 2, I get 4. So those are what I'm subtracting. 20 minus 4 makes for 16. And 16 divided by 4 equals 4. So our average rate of change is 4. That's it. If you need help on the assignment, whoa, phone's going nuts, sorry. Okay, if you need help on the assignment, feel free to message me about anything. We might be able to post an answer key or something along those lines, so be looking for those. Stop calling me. Okay, that's it. If you have any questions or anything that gets unresolved, you guys can always bring your questions back on Wednesday. Okay, thank you so much. Have a good one.